For decades, Bengal placed its faith in engineering, dams, reservoirs, barrages, embankments, structures designed to tame rivers that once flooded with devastating force. And yet, even today, the floods still return. So the question is no longer simply, can floods be controlled? But whether modern flood management has entered a new era of complexity. Long before modern flood control systems existed, the Damodar River was widely feared for its destructive floods. It earned a name that echoed across Bengal, the Sorrow of Bengal. Entire settlements were repeatedly devastated by seasonal inundation. Agriculture suffered, transport collapsed, economic activity slowed. In response, post-independence India embraced a new vision. Large-scale river valley engineering. The Damodar Valley Corporation, or DVC, emerged as one of the country's earliest multi-purpose river valley projects. Its mission was ambitious. Moderate floods, generate power, support irrigation, enable regional development. For its time, it represented engineering optimism on a national scale. The DVC system operates through a network of dams, reservoirs, barrages, and regulated releases. During monsoon months, reservoirs attempt to capture part of the incoming floodwater. This process is known as flood moderation. By temporarily storing water upstream, the system aims to reduce the intensity of downstream flooding. At the same time, the stored water supports multiple competing needs: irrigation, power generation, industrial demand, and dry season water supply. But reservoir management is never static. Operators must constantly balance changing inflows, storage levels, weather forecasts, and downstream river conditions, often in real time. And during extreme rainfall events, those decisions become increasingly difficult. Modern flood control systems are built around assumptions. Assumptions about rainfall intensity, catchment response, river carrying capacity, and seasonal predictability. But climate variability is changing those assumptions. Rainfall events are becoming more concentrated and erratic. Large inflows can arrive rapidly across multiple catchments at the same time, and reservoirs face a fundamental operational challenge. A reservoir cannot remain completely empty for flood storage, while also remaining full for irrigation, power generation, and water security. This creates a continuous balancing act between preparedness and utilization. Under extreme conditions, controlled releases may still become necessary, not because systems have failed entirely, but because river management itself involves unavoidable physical limits. Alongside dams and reservoirs, Bengal also expanded another major strategy: embankments. These structures were designed to shield settlements and agricultural land from seasonal flooding, and in many places, they did provide protection. But rivers are dynamic systems. When floodwaters remain confined repeatedly within narrow channels, sediment often begins accumulating along riverbeds over time. Gradually, the riverbed may rise, and as urban expansion and encroachment continue reducing natural floodplain space, the pressure inside the river system increases further. Sometimes the river rises not only because water increased, but because space decreased. And when embankments fail under extreme pressure, the resulting flood can become sudden and destructive. For many low-lying regions of Bengal, flooding is no longer only a river problem. It is also a drainage problem. Once water spreads across floodplains, its ability to escape becomes critically important. But silted channels, blocked drainage paths, and expanding settlements often slow that process dramatically. The result is prolonged waterlogging. Communities remain submerged not simply because rivers overflowed, but because the landscape can no longer drain efficiently afterward. And for families living in these vulnerable zones, recovery becomes a recurring struggle. Across the world, flood management philosophies are beginning to evolve. The focus is gradually shifting from absolute control toward adaptive coexistence. Engineers and planners are increasingly exploring basin-wide coordination, improved forecasting systems, floodplain zoning, wetland restoration, and creating more room for rivers during extreme events. The challenge facing Bengal may not be whether floods can be eliminated completely, but whether future systems can become more resilient, flexible, and climate responsive. For generations, Bengal tried to defend itself from water through engineering alone. And much of that engineering changed lives profoundly. But rivers were never static. They shift, adapt, expand, and remember their floodplains. Perhaps the future of flood management will depend not only on resisting water, but on deciding where it should be allowed to go before it chooses on its own. Flowline Chronicles, Engineering Earth's Balance.